We have a test before Thanksgiving break. I do not know yet whether it will be Friday, Monday, or Tuesday. Plan for probably Tuesday before Thanksgiving. So that gives us all this week. Monday is a review day, Tuesday for the test. Okay? That does a couple things. If you're planning on leaving early, you should probably say, hey, Mr. H, I'm not going to be here that Tuesday because you'll take it on Monday. You're like, oh, that's not fair. Yeah, it is. I win. I'm pretty fair. We are still in Unit 3. We are doing what are called functions. And we are on day 4. 4? 4. Today we are going to start to graph. First and foremost, we can graph any function. It does not matter how much we are given. It does not matter what the function looks like. It does not, we can graph. If I say, here is a function, you will be able to graph it by the end of this lesson. Not necessarily today, but hopefully by tomorrow or Wednesday, you will be able to graph any function whatsoever. Okay? We can graph any function. When I say graph, I mean we're going to have some kind of line on a coordinate plane where we're counting our x's and our y's, we're putting a point, we're connecting our dots together. We can graph any function whatsoever. Everybody with me? Okay. Today, we are talking about linear functions. When I talk about a linear function, what word jumps out of the word linear? Lydia. Line. Line jumps out of the word linear. If I were to graph a linear function, do you think it's going to look like a U, like an S? Like a straight line? What do you think a linear function will look like? Maverick. It will be a straight line. Linear functions for us will look f of x equals x. That's a linear function. F of x equals x minus 7. That is a linear function. F of x equals 5x minus 2. That is a linear function. F of x equals 7 minus 5x. That is a linear function. So all of these are linear functions. Yes, Sam?
Can you please give some examples of what wouldn't qualify as a linear function?
I bet that's going to happen next. So what makes them linear functions? The key here is it's just x. Nothing is with my x as far as an exponent. As soon as x has an exponent other than 1, it will not be a linear function. So if I have f of x equals x squared, it is no longer linear. And we're going to talk about that tomorrow because it's called quadratic. So if I have f of x equals x squared minus 7, it looks really similar to x minus 7, but because it has x squared, it is not a linear function. Another one that will not be a linear function is x to the 3rd power. We'll be graphing those as well, and those are called cubics. We'll talk about those tomorrow. But as soon as our x has an exponent other than 1, these are non-linear linear. Which means if I were to graph them, would they be a straight line? No. Nonlinear graphs are not straight lines. Linear must be straight lines. Everybody with me? Okay. So go ahead and get caught up. Caught them all down. You are going to see problems that look like this. It's going to say graph. And then it will give you a function. F of x equals x plus 1. Eventually, I will teach you a way to graph functions without making a t-chart. But right now, you will still have to use that input-output, that t-chart, whatever you want to call it. You'll still need to make that. So, before, I've given you values for x, right? And you've substituted in to find the y's. Does everybody agree with that? Because we did that on our warm-up, yes? Okay. Now you get to choose. It's truly up to you to choose what numbers to substitute in for x. Now, if I were a betting man, I'd probably place a pretty large wager that I'm going to give you numbers that you should use. If I were a betting man. If it's a linear function, if it is linear, I would use 3 numbers. And I will almost 95% of the time use the same 3 numbers every single time. I will use positive 1. I will use 0. I will use negative 1. Why? Because I like to keep the numbers small. If Michaela said, Mr. H, I want to use 27. Hey, go for it. Use 27. Do you want to graph all the way out to 27? Me either. Remember, the end game is graphing. So, what do we need to do now to find my ordered pairs? What do we have to do to find y? Not graph. What have we been doing so far? What?
Linear lines.
Well, yeah, we're doing linear functions, but what do we have to do? We have to, I heard it. Yeah, we have to solve. We have to substitute in. So I'm going to take this x, and I'm going to say f of x equals, well, what's x? My x value is 1. So I have 1 plus 1, which is 2. This is an ordered pair when we graph. F of x equals, parentheses, plus 1. What am I going to substitute in for this one? 0. So now I have 0 plus 1, which is 1. Huh. You might be saying to yourself, Mr. H, this looks very similar to what we've been doing. Yes, it's exactly what we've been doing. It's a function table. So now we have f of x equals, parentheses, plus 1. What's negative 1 plus 1, which is 0. I now have 3 ordered pairs that I can graph. Okay, so when I graph these, I've got my coordinate plane. So this is y, this is x. And you're going to have to make your own coordinate plane. So I'm going to go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. This is negative 1, this is negative 1, 1, 1. Everybody with me? Okay. So we are going to graph our first ordered pair. My first ordered pair is 1, 2. So I start by hovering over my origin. I go over to 1, I go up 1, 2, I put a point. Everybody with me? So now, my next ordered pair is 0, 1. I hover over my origin. It goes 0 places on the x, so I don't move, but it says go up 1. Then it says negative 1, 0, so I go left 1. Okay, there's my ordered pairs. Is that how I should graph this function? What did we say linear functions should look like?
A straight line.
A straight line. Will mine be a little bit off because I made up my own graph? Probably. But we're going to need a straight line that extends forever in both directions. And this is the part that gets people confused. Can anybody tell me why it has to extend forever in both directions? What does that line represent? What does that line represent? And I'll be very impressed if somebody can get that. Anybody want to give it a go? Well, let's start with this point. What did this point represent? 1, 2. A solution for this equation, correct? When I substitute in 1, I get 2. So 1, 2 is a solution. What about 0, 1? Was that a solution? What about negative 1, 0? Was that a solution? Okay. What do you think this line represents? Go ahead, Ava. Close. Not how many solutions that we've got, because there's an infinite number of solutions. Give me another number. All right, give me a number.
3.
3. Good. With the psi and everything. 3. Okay, so I substituted in. 3 plus 1 is 4. Okay? This was originally not graphed. Does everybody agree with that? 1, 2, 3, up 1, 2, 3, 4. Holy crap. Wait a minute. That solution was already on the graph. Everywhere this line is a possible solution to this function. Do we have to use whole numbers? Could I use 1/2? I could say f of x equals 1/2 plus 1. Well, what's 1/2 plus 1? 1 1/2 over 3 halves, which is 1 1/2. So if I go up 1/2, up 1 1/2, wait a minute. It's on that graph. Every single place where that line is a solution. That's why we have the line going forever. Because you can think of any single number. Every number will work for this function. Give me a big number. 20. 20 plus 1 is 21. So I could graph 20, 21 and it would be on this graph. I could graph negative 1 million and it would be on this graph if that line continues forever. Questions on this? I mean, this really shouldn't be hard. Shouldn't be. So let's say I give you f of x equals 3x minus 3. And I tell you to graph. There are 2 steps that you need to do. First, you need to make your own XY chart. Make your T chart. How many numbers must you have to graph that I'm asking you to have? Show me with your fingers. Yeah, you must have at least 3 points. Could you have more? Sure. You must have 3 points. Does Maverick's 3 points have to be the same as Justin's? No. But I would use my 3 points here. That's just me. So, go ahead and make your T chart. Substitute in 3 points for x. So the function is f of x equals 3x minus 3. So one more time, f of x equals 3x minus 3. F of x equals 3x minus 3.
Minus 3. Then make your table. So you need to pick 3 numbers for x. What are the easiest numbers to pick? for negative 1, 0, and 1. So go ahead and do that, and then solve for those numbers, okay? Solve. Do the table, go ahead and solve for each of those are going to be x. So what, go ahead and solve for this. And solve for, you can do that. A 0. You can't, they have to be 3.
Oh.
Okay. So just what are the 3 numbers? The first one, 1, 0, negative 1. Okay. Now solve it. Put it in there.
I'm gonna give you one more minute just to do the T-chart. You might not be done with graphing, but I want us to at least have the T-chart done so that we're all on the same page when we start to graph.
You can do this.
On this. Do you like to show my work on this or not? Okay.
You should always.
Okay, so it does not matter. Oscar, what 3 numbers did you choose for x?
2, 4, and 3.
2 what?
2, 3, and 4.
2, 3, and 4. Okay? Is there anything wrong with those? Absolutely not. Are those the numbers that I would have chosen? No. I like to have a positive, 0, and negative. But that's just me. I would always use 1, 0, negative 1. But watch, it's going to work just fine. So when we substitute in 2, I say f of x equals 3 times 2 minus 3. That's 6 minus 3, which is 3. F of x equals 3 times 3 minus 3. That's 9 minus 3, which is 6. Already my graph's bigger than I really want to graph, but that's all right. F of x equals 3 times 4 minus 3. That gives me 12 minus 3, which is 9. Once I have 3 points, I can absolutely graph it. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. 2, 3, 4, 5. Okay, so here we go. 2, comma, 3. Hover over the origin. 1, 2, up 1, 2, 3. Over 1, 2, 3, up 1, 2, 3, 4, 5, 6. Over 4, 1, 2, 3, 4, up 9. Now, is my graph perfect?
Nope.
No, because I drew it, right? If I give you graph paper, it will absolutely be perfect, so the lines will work a little bit better. You can see which numbers are going to work. So mine's a little off. But I'm looking something like this. Okay? What other numbers did we use? Emily, what number did you use?
1, 2, and 5.
Okay, so let's use 1 now. So 1 goes in, that's 3 times 1 minus 3. So that's 3 times 1 is 3 minus 3 is 0. So I should have 1 comma 0. Well, I'm close. My line's a little bit off. But does that still work? Okay? Again, when I ask you to graph, I will ask you to graph on graph paper. Right now you're going to make them. Are they going to be a little bit off? Yeah. On your test and quiz, I will give you a graph to graph with. Does that make sense? So, if my graph looks a little bit different than Emily's graph, is that all right? Yeah. Okay. You've got 2 problems that we're going to go over before the end of class. That's it.